comments. We have people. It
We
looks like.
do. There's a good crew out there watching.
Yeah, I got
So,
that Sherry Asplin retweet. I mean, put it on Facebook, so that's awesome.
Yay.
so before we go live and start the show, I'm just going to give a shout out to everyone out in the audience on this May the 4th. May the 4th be with you. I am wearing my one and only Star Wars shirt. It says, "Come to the dark side. We have cookies." Signed V. Um, it turns out I need more Star Wars shirts. Life goals, squad goals. Um, so welcome
Me too.
everyone to our 110th episode of Learning Space.
Woo.
I am Dr. Pamela Gay. With me is my co-host, as always, Georgia Bracy,
Hello,
and
everybody.
we have special guest Whitney Kobe from the Corel International joining us this week.
That'd be Whitney Cobb.
Oh, geez. I only type your name. I'm so sorry. I know
No
how
worries.
these are the things that happen when you interview people from the internet. You learn how to pronounce their names. And I see that we have a great group of people out there in our live audience joining us this week. We have Nancy Graziano, Phil Wilcox, Guido Vibra, Larry Beckham, Michael Jobin. Oh, it's scrolling past me. Um,
And
if
talk
I'm
about pronouncing names. I'm
Yes.
glad it's you, not me.
So if I missed saying your name while things were scrolling, welcome. And this show is made possible thanks to all of you. If this is your first time watching, this is a Patreon-supported show, and you can learn more about us at patreon.com/learningspace. So,
Yay. So we have a wonderful guest with us today. I'm very excited because I've heard Whitney talk a lot about the program that she's going to tell us all about today. And so I thought she just has to come out on Learning Space and tell everybody else about the program too. She works with teachers, Whitney does. She works at McCrell. And actually I'm going to start, Whitney, by just having you tell everybody a little bit about your background and what you do, and then we can go right into the program.
All right, thank you. I am at McCrell International, which is a research and evaluation and education laboratory, and the labs are classrooms and schools and districts and all kinds of wonderful learning environments that are out there. And I get to do a lot of great work with NASA's Discovery and New Frontiers program, particularly in their engagement and communications areas, and then also on my beloved mission, the Dawn mission, which has been a partner with CosmoQuest for a number of years. We have asteroid mappers, which is a marvelous citizen science project we're very proud of. And so today I'm here with really a collaboration between our work at McCrell, some colleagues, wonderful artists here in the city of Denver, where I'm located, Monica and Tyler Aiello from Eurekis. They're artists and extremely innovative STEAM people, and they developed, along with the Discovery program and Sherry Asplund, Art and a Cosmic Connection, which turns out to be a terrific segue or way to tune the observation skills for people who are interested in becoming a citizen scientist and a CosmoQuest mapper.
Yeah, so Whitney's a great ambassador for CosmoQuest, and in fact she is one of our collaborators on the big new NASA grant that a lot of you have heard us talk about recently, so we're getting to know her better and better all the time. Whitney, tell us briefly about STEAM. You mentioned STEAM, and I know probably not everybody just gets that little acronym, so real brief.
I know sometimes in education we have so many acronyms, and science is the same way, and I think, no more, but
There's always more.
I know, I rather love. So we all know STEM, science, technology, engineering, mathematics, and STEAM is where you add the arts and actually really give some projects and some learning some STEAM, not to be too corny. But at any rate, I think for me, STEAM, when you are able to integrate the arts into science, it draws out different components. It's very engaging. We often find people who are sometimes reluctant or shy, they don't feel very confident in STEM. When there's an arts element, they pause, they wait, they listen, they start to get engaged, and all of a sudden they're finding that they can be scientists, they can be engineers with that opportunity. And so, so at any rate, this is a very specific one here, art and a cosmic connection.
Right. So Pamela's, let's see, got the website up for it. Hold on. And go ahead and tell us a little bit about what we're looking at now. So this is just the first lovely picture here.
Yeah. So this was, again, a concept that really arose from Monica and Tyler Aiello on Eurekis here in Denver. And their concept was to use, we get these gorgeous images from outer space, from all over the solar system. And a lot of times, I have this little story. I'm on the Dawn mission, and we arrived at protoplanet or giant asteroid Vesta back in 2011, and I came home. I was so excited. I ran up, up the sidewalk to my home and burst in the door. We made it. We did it. We got the first images ever that we'd ever gotten from Vesta that were better than the pixelated, wonderful but still pixelated images from Hubble Space Telescope. And I was so excited, and I come bursting in, and my daughter's all happy for me, and she goes, well, show me, show me. And I show her the first picture of Vesta, and she goes, well, that's nice, Mom. And I was like, it's just another rock in the sky to you, isn't it? And so that actually kind of encapsulates, I think, the dilemma we have. How do we help people engage with images, like have their, not only seeing this gorgeous image right here of Mars, but also have their imagination peak, to be able to imagine where Mars is, how far it is. This is a colorized image here that helps us understand the mineral composition of the surface. And so, at any rate, I think that this is a way to help learners engage using the elements of art as a tool to hone analysis. So I think our next slide is the third slide. Is that right, Georgia? I think so. Yeah, there we go. So this is an image of giant asteroid Vesta, a crater there. And you might be familiar with this. This might be 101 for you, but the elements of art that really help artists interpret all kinds of things are line, shape, color, value, and texture. And so we use these tools in this program. And this program, by the way, is all free and downloadable. There's a beautiful poster. There's an interactive, the poster is interactive, so you can see artists and the art, the images that inspired their art, and the art there are all kinds of great resources for really any kind of learner. So at any rate, but here you see the kind of introduction to that. I think we popped from here to, I would actually,
if you want to add anything else,
yeah, go right ahead. Go to the next slide, because I think that intro, we don't want to believe spend too much time talking, but so here's an example of where shape, in this case circles, is equivalent to a geological feature, and here it's craters, and in the hour, most of the time, sometimes you'll get some other features, and on Earth, of course, circles, any kind of geometric shape usually is an indicator of human impact. But at any rate, when you see a crater on Mercury or the Moon or Mars, that is generally an indication of some kind of impact. And so if we go to the next slide, that's number 5. So here is an image of Mercury. And so we spend time, I've done this activity with literally all ages, third graders to all kinds of adults. And so here you can see this is this beautiful image of Mercury. And you can begin by thinking about the craters here to interpret this surface. And so the question I always ask is, what's an old crater on this surface? And what's your evidence that it's old? And so we will have a great conversation. I'll have learners come up and engage with the engage with the image and the different stories it tells, because and then we talk about how for example, in this large crater in the upper right-hand quadrant, they see that as an older crater because it has some evidence of weathering, and there are craters on top of that. But then they begin to see that sort of crater to the south east of that, and they see the young crater in there, some of the little crater images, things like that. So at any rate, let's go ahead and go to the next slide. Thank you. So here's just a fun, these are craters throughout the solar system. We've got that double crater on Mars, which is awesome, and just makes you wonder, like, how on Earth did that, or not, now how on Mars did that ever arrive? Just double impact side by side. They look like they're the same age crater. It's just marvelous. And then we have these colorized images. I'm pretty sure of those are of the moon, where the one on the right, that upper right, is indicative of some of the different water that's embedded in some of the rocky surfaces. We have Vesta on the lower left. We have craters. We talk a lot about how when you have a chance to personally engage, so if you look at, this is Mickey Mouse crater on Mercury, and they had a wonderful naming convention which brought in all kinds of humanities connections as they named the craters on Mercury, and that was Mickey Mouse crater. And then these wonderful craters, I think those are both from Mars on the bottom left. And you can see the one that you can really see the ejecta. So at any rate, it gets you thinking about the stories of the solar system. So let me move on. Let's go to, let's see, let's go down. I'm sorry, where are we? Let's go to image 8 briefly. So here, we're still looking at shape, but you can see we're looking at organic shapes. Yeah, organic shapes. So this is a volcano on, I'm pretty sure this is on Mars as well, and you can see it has this, we talk at blobs. I know that when we were running this through the NASA assessment, they were a little grumpy about squiggly lines and blobs, but I'll tell you, sometimes blobs and squiggly lines just tell it the way it is. So at any rate, so here you can see, when you see a blobby shape, that indicates maybe it's a volcano. The other thing it might be is sometimes it's lakes, and those lakes don't have to only be on Earth. We think of those as an Earth object, but Titan has lakes, but it has different liquid in its surface. in its lakes that are in that very cold environment. So we've gone shape, both geometric and organic. Let's go ahead and go to, well, let's go to slide number 11. And so here we have straight lines, and we see a straight line. That's indicative of tectonics, some kind of tectonic activities. It's cracks and fault lines. This, of course, is the glorious Europa, one of the Jovian moons, and you can see this blow up of the surface there. I think these were collected by Galileo, and so when you see a line like this, that's an indication there was some kind of movement on the surface of that world. So let's move from here let's go ahead to the next slide. That's a 12. And here, so we had straight lines for tectonics, and here we have squiggly lines. So again, a highly scientific term, but squiggly lines are indicators of some kind of erosion. They could be liquid. This is Mars. They can be wind. And so it gets a lot of stories about what kinds of forces are in action in that area. There are some squiggly lines. There were some in Vesta where we thought there wouldn't be any. And those squiggly lines ended up being indicators of some places where it looks like in the early history of that really terrestrial kind of dry, rocky world that there was some different kinds of volatiles mixed into those rocky surfaces that made it flow, that gave it that squiggle. So again, what we hear when people have a chance to engage with this is that there's a lot of excitement about their quick ability to start interpreting these cool surfaces.
I love the name that, you know, these things have, squiggly lines and blobs. So I don't know, squiggly is a technical term maybe,
Right.
so but it's great.
So what's really awesome is squiggly lines is a term that all of the scientists use, but liquid and wind aren't words they use. They instead say, in place of liquid, fluvial, and in place of wind, aeolian.
We might end up keeping liquid and wind on here. I don't know. But I love those words, fluvial. Alrighty. So then, let's go to number, actually, let's go to the next one. Let's go ahead and go to 13. So this is just a very beautiful image of Mars. I always ask my peeps that I'm working with what they think this is and what is kind of reminiscent of something they've seen. And eventually we get to a point where they start recognizing this as dunes, wonderful dunes on Mars.
Beautiful.
See, these squiggly lines are quite different than the ones that are thought to have been caused by more fluvial forces. So let's go ahead and go to the next one just for a little variation here. So here we have squiggly lines, and of course this is a beautiful image of Earth. This is from Siberia, and it's also been colorized as it happens, but you know, this is obviously an indicator of these beautiful this beautiful alluvial fan, and it just, I don't know, I just love this image. So and then if we move to the next image, so then we have a chance to talk about color. And a lot of the worlds in our solar system are pretty gray worlds. They're fairly black and white. But scientists use color in all kinds of ways. And this color image of the moon here on the right, glorious, 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 beautiful picture. And we have a, you know, CosmoQuest is a wonderful moon mappers program that gets you exploring the moon more carefully. But this one has been colorized to to give an indication of the mineral composition of the surface of the moon, and it uses, I'm quite sure, a variety of data from different missions that they overlap, is so that a lot of times they'll use a combination of data to come to a better understanding of something. So at any rate, so here's colorization, but it's not just out of a whim, even though I think it's very beautiful myself, but it also has a scientific purpose. So let's go ahead and scoot down to, I'm not sure if it'll show or not. We can try number 16. Can we see the original slide on that one before it's, because it was, it's Iapetus.
That was a sequence, right?
Sequence, it was. Is that possible to show that?
I'm sorry, we converted everything into images to share on the Hangout. Let me see if, in fact, I know that I can't do that using the software I have with me. I'm so sorry.
Don't worry about it. So this is Iapetus. If you want to Google images on for Iapetus, this is a beautiful moon of Saturn, and it has a very dramatic, it has some of the lightest, brightest, and the darkest areas, especially in contrast in the solar system. And so that is value. That's the artist's concept of value. We call it albedo, which is basically a measure of the reflectance of the surface. But we find, I'm always delighted by the number of people who choose black and white images and then really have a lot of fun examining the texture and the color and the variety in those images, and that they can, and sometimes they colorize them because they're the artists, because you take an image that you're passionate about and you create your own art. So let's go ahead. The final one, this is going to be the same issue on the next one, which is 17. And I'm trying to think which one this is now. I'm forgetting. Do you remember which one this is, Pamela? That cantaloupe surface, they call it a cantaloupe surface?
is that I can't remember, and I should.
Okay, Pamela, we're not.
Oh, wait,
Oh,
now
I'm
we can't
sorry, I
hear
was
Pamela.
muted. What I was
Okay.
saying is, hold on just 1 second. I was trying to bring you Iapetus, and now all it will let me show you is Iapetus.
There we go.
So one moment, and I'll have the rest of the slide deck back. Mistakes were made. And if any of you see Whitney periodically laughing for unknown reasons, it's because we have a back channel. And the reason my voice is somewhat rough today is I have horrible hay fever. And I keep muting my microphone so all you lovely people don't have to hear me blowing my nose. And Google keeps asking me, are you speaking? Do you need to unmute your microphone? And it's like, no, really, they don't need to hear this. It's okay, Google.
So the cantaloupe guy is Triton.
That's exactly right.
One of the moons of Neptune.
Yeah.
So I don't know. Yeah. And so there we have Iapetus. And I was going to ask you, so this is kind of what the interactive poster does, right? In a way, Whitney, where it shows you some of the art, and then you click on it and you see the underlying real thing, in other words.
That's right. So we developed a poster. We went to a school here in Denver, and we actually offered this activity to a bunch of high school students and middle school students, and then we selected artwork from this student work to create a poster. So there's Iapetus, and then this is representing what they literally call the cantaloupe surface on the moon of Triton, which is a moon of Neptune. And then let's go ahead and we can go to the. Do you want to go straight to the poster? What do you think? What are we doing? We're doing 4:50. We're 53 my time.
We're actually fine with time if there's anything else you want to highlight or anything.
If you don't mind, let's go ahead and back up and take a look at. So here is an image, exactly 19 there. So in the slide deck that you have access to, this actually is an opportunity for yourself and your audience to engage with this beautiful colorized image from Mars. And so we begin by looking for, you can see all the circles, you begin by looking for the shapes that you see. So you have the geometric shapes, the circles. Then you see you've got this big blue blobby shape. And so what we've done is that as you go through the elements of art, each one of these will pop up. So it's a wonderful way to kind of get people looking closely, and then for you to have a conversation about, kind of what you see. So we have the circles, we have the blobby shapes. You can see there's also these wonderful row of blobby shapes down here on the lower left-hand side there. Those are some volcanoes on Mars. There's another one at the top. So then from there, we start looking for the straight lines, and you can see these straight lines, which are indicative of, again, tectonics, and how you can see the squiggly lines, which are indicators of some kind of erosion, and then it makes you wonder, like you could see that the tectonic, the fault lines there, some of those are parallel with the squiggly lines, so it makes you wonder how they interact with each other. And then, of course, the whole image is colorized, and then you really see a lot of beautiful texture. This, relatively, this surface on the right-hand side is probably a little bit older because of all the cratering, whereas on the left-hand side you can see that there's probably some flow. It's smoother, and that's probably from that volcanic action. So one of the things that's super cool about Art in a Cosmic Connection is it just gets you thinking about the stories that the geology on these beautiful worlds tells you, and at the same time you're getting to do this terrific art, so it's sort of win all the way around.
Right. And you're honing your observation skills,
do.
right? Because I'm noticing, looking at all of these things that people have drawn on this picture, just makes you, it kind of draws you into the picture itself even deeper. Because now I see all the craters that people have, outlined, but then I look and there's even more than that, right? There's teeny tinier craters in there, and there's more squiggles, and there's more blobs, and there's more lines that I don't know if I would have noticed all of that just looking at the picture itself, but those added details from the drawings really kind of bring you in.
Exactly. And another thing, this colorization here is topography, the relative altitude, and so you can see that the blue is the lowest, and then the green, and then it segues into the yellow and the orange, and then up to the red and the pink and kind of these gray are the highest altitudes there. And so that also kind of, tells more of the story and helps you be able to envision here. Like if this were all gray, it would be a little bit harder for you to perceive where volcanic activity, where there might have been flow, where there were other forces that maybe cut into that. And you know what, I was talking to some people a little while ago, and one guy was really anxious because he was like, we're going to get it wrong. We're going to say the wrong thing. We're going to think it's this, and it's not that at all. And he was really worried that, that you were going to kind of unleash a monster when people start coming in here and, interpreting it on their own. And so, we had a great conversation about it. And what we came to was, first of all, that's what scientists do, right? We have, looked in the sky, looked through our telescopes, looked at the world around us, made assumptions, made hypotheses and suppositions, and oftentimes with more evidence we find out that we end up rethinking our understanding of something, and that's the process of science. And so it's okay if you've come and say, I know it's this, and then you're like, oh, turns out that wasn't, you thought that was a crater, but that was actually a pancake dome volcano, which is what you have on Venus. You have these pancake dome, peculiar, kind of wonderful volcanoes that kind of rise up. Then you just, just again, it's the more power of having our thinking challenged and all that kind of good stuff. So I'll stop.
Right. Well, I was also thinking something similar as far as art goes. So you're bringing art into this, and I wonder if you get a lot of teachers, because I think I would be one, that would say, oh, I'm not an artist, I can't draw, I don't know anything about art. That's why I was interested in one of those earlier slides you showed with the, 4 or 5 different, sort of components of art, the texture, because I never thought about that before. And then, I always get nervous when someone says, now we're going to draw this. Draw a picture of, yourself, and oh my gosh, I'm not an artist. So do you get any of that, and how do you?
Sure, of course we do. I think that's the facts, right? I think that we teachers. I was a teacher for many years before I started McCrell. I still consider myself a teacher, and it's hard to do this. It's hard to do art or engineering or like I'm confident in planetary science, but I'm not confident in physics or whatever. Sometimes we're nervous about moving forward, but I think it's a great way to keep in mind that's what our students experience, right? Or that's what our fellow learners experience. We get uncomfortable. Like, learning's uncomfortable. The fear of failure is uncomfortable. And yet, one of the things that we really push with our STEAM work is that failure is opportunity. And so we, let's see. So one of the things is that there are lots of little elements on here where a teacher can learn alongside. So first of all, we always encourage everybody to do the art. So for example, I have a wonderful colleague here at McCrell, and here we go, here we are. So I have a wonderful colleague here at McCrell who is coming with me to do a bunch of presentations at the Girls in STEM conference here in Colorado, in Denver, for young front-range women who are interested in STEM. It's from or promoted by the women in the Society of Women Engineers. Forgive me, lumping around there. But at any rate, they Laura is going to actually do the activity. So she's going to do the activity with the girls because she's never done it before. And I think so. Part of it is that when you do your own, you have a blast. Second of all, it's your art, and so it doesn't have to be you're exploring a scientific sort of world and data on one hand, but you're doing your own interpretation. You're making it for yourself, so it's okay if you do different things with it. So it does promote that kind of learning alongside, which I think is with a lot of the STEM initiatives where we're pushing into realms where we're not as knowledgeable and confident sometimes. This is great practice, I think, and keeping in touch with our inner learner and helping us ensure that our stuff is dynamic and engaging and interesting. And sometimes that's because we're taking risks.
Right, and as you say, just reminding us of how our students feel and how we felt when we were students, and we still feel that way about some things today. So that's a feeling that's always with us, and it's a part of learning.
It is, and it's a wonderful part of learning. Wonderful, wonderful part of learning. So this, whoopsie, I was going to talk about that little poster thing in 1 more minute here, and then after we got a nice asteroid mappers final thing too. If you don't mind. So unless you had some, I'm sorry, Pamela, if you had something you wanted to share, so if this we're cool.
No, I think she can. I think she's just getting ready to share.
Okay.
That is the poster, the interactive poster, correct?
Exactly. So this, when you go on to the Art and the Cosmic Connection page, all the materials are there. And when you open up this and click on one of these images here, up will come a bar that has the image that inspired the art itself, and then the artist at work. So these are from, again, all kinds of age kids in different worlds in the solar system.
All students, right? All kids?
That's right.
Because they're beautiful.
That kind of activity broken down into shape, line, color. It has an overview, and so it's a big poster. But you can, if you're on a tablet, for example, you can click on one section, and up will come just a nice little synopsis of shape, or a nice little synopsis of color or texture. And so there's lots of ways that you could engage your students with this. I mean, if I were working, for example, with elementary or older elementary kids, and we had access to tablets, I'd go have them work in pairs or trios and investigate, instead of having me talking at the front, have them investigate through this poster and then come back and share out some of the things they learned and use that to kind of galvanize them. I always start by spreading out like that kind of like the match, the excitement. So I start by spreading out all these beautiful images. We have these images. We have ours. You, of course, should have a wonderful time digging up your own favorite NASA images and images from other space missions as well. But at any rate, we start off with that so that people will go and they'll pick and they'll find an image. This is Io. Right here, this one on the second up, Europa is the one on the bottom right, and right above that is Io. Vesta is there in the bottom middle. The moon is there on the left. And so they've already found some image that they just think is really beautiful and interesting to them. Then they find out about how to use this elements of art to help engage and interpret these surfaces better, and then they go for it and they make their art. And as you can see, I love to use huge sheets of paper. Sometimes time doesn't really allow for that, but it's wonderful if you spend time doing that.
And it looks like you're using everything from pastel chalk to like some people like black and white, so just pencil and there you go.
So these are soft pastels.
Anything works, right?
Right. Soft pastels, and you can spend a small fortune on pastels. But these are just grade pastels.
It's true.
$4.99 for a set. The other thing about them is that they are they're one of those things that breaks the laws of physics, where somehow you have more room afterwards, because they just break and then you reset them and everything. But they last forever because you can really draw with them right down the nubs. It is a little dusty. We're definitely not using the oil pastels. Those are great. Those are their own kind of, set of issues. I brought, it's a very exciting pad of paper, but it is a charcoal paper. It has a little bit of a nap, has a little texture, which means that it can color well. The soft pastels are great because they're so vibrant. You can see in these here how beautiful and vibrant they are. We'll use little things like, let's see if I had some, well, this isn't a very good example of it, but it's basically Q-tips and cotton balls and things like that to smear, that kind of thing. And then wipes. We just use, like, little towelettes, wipes to clean up. You want to definitely do it on a newspaper surface. But it's a relatively inexpensive opportunity to engage with some beautiful images. And then the other thing that I love and I've done with it, if you want to go, Pamela, to the very last slide, number 24. So here's an example of one of the wonderful mapping programs that CosmoQuest has developed. And here it is. This is Vesta Mappers, and we did a little sample. And I actually think it's evolved a little bit since here, but you can see the tutorial there on the left. And then this has been a combination. I think this was marking some boulders and looking for some interesting features, and of course these craters here. And as you can see, not all the craters have been found. Yeah, you can see some more. But what happens is that, when I have people who have done Art in a Cosmic Connection then come to one of these mapping programs, all of a sudden, they're imagining this world in a way, and it makes it much more compelling. And then the additional storyline that you're actually contributing to the Dawn mission and to the kind of the store of knowledge and understanding that is constantly being evolved in humanity in general, it's pretty special.
It is. It's really powerful that you're, contributing to science. And I can see what you mean. You look at that interface now in the computer, and you get the Dawn or sorry, Vesta, excuse me, and you're seeing all the craters. But now, after having done the art, I think I was imagining, all the colors, all the different things that I could potentially look at this, and find on this picture. So I really think it does enhance your observing skills. It's pretty amazing.
I've been pretty, I did it, so sometimes we do a NASA week, and I went to Huntsville, near Huntsville, Alabama, Rainsville, and we spent a whole week, and I did Art in a Cosmic Connection with everything from AP chemistry to fourth graders. The fourth graders is a bit of a stretch because they hadn't learned about the solar system or even any geology yet. So they didn't know what a volcano was, or a lot of the things that we took.
Oh, yeah.
By fifth grade, they knew it. And we had a wonderful time in the high school because the class that was considered the low class turned out to be, they're very shy and they were very quiet. But they happen to be very visual, and so the most beautiful art rose from the slow,
right. Finger quotes, yes.
Exactly.
Air quotes, whatever it is.
Exactly, because it was they were looking at their capacity to verbalize and that kind of thing. These kids were very shy. They're adorable, and it took them, like, I had to really pull it out of them, and we actually went sooner to the art because once they started doing the art, then they were more comfortable sharing the stories and their observations. But they were extremely perceptive, and so it was just, we did it all week long. That was our pilot. We did this massive pilot, got all this feedback from all these different age people, and it was a kick in the pants. So
we have a question coming in from Guido Vibra, who asks, is there a printable version of the poster somewhere? It begs to be printed even if it's non-interactive.
Well,
it does.
I agree. We actually do have, it is printable, so you can, it's right on the website, it's printable. And, I can give you my email, and I can send you one of, did I bring one? I had one. Let's see, maybe once. Well, anyway, I could send you. We did print some out, so I'll put my email on here, and
we'll put information on the website, and Whitney, some things about you and any other contact information. I know you said you're on Facebook, you're on Twitter, or at least as McCrell, right? STEM McCrell. So we'll put that all on the Educator Zone blog.
Okay, awesome.
For this.
So this has been a truly fabulous episode, and Whitney, you were a fabulous guest in so many ways, and in this week in particular, while I sat snuffling behind your artwork, it was fabulous to have someone who just has a message that is so visually appealing and can just talk and share something of real beauty. And I love your closing message that the students whose intelligence we don't always appreciate with mainstream metrics really had a chance to shine when they were asked to communicate through art instead of communicate through the normal verbal ways that we ask people to share. It's a really awesome message and a powerful aspect of this tool that you're presenting. This has been 40 minutes of a 30-minute show, and
Yay.
I'm really appreciative of our audience sticking it out the entire time. So Whitney, where should people start to go learn more about what you're doing?
Well, if actually, I think if you were just to throw into Google art in the cosmic connection, and especially if you added NASA to that, should lead you right to the page. It's on the NASA's Discovery program. The NASA Discovery missions are these smaller robotic missions. New Frontiers is a little bit larger missions, and so this is kind of an umbrella program, and it's really working for engagement and communications and kind of helping enhance people's literacy. And a lot of the passion that we have for that is using STEM and really working to evolve materials that make all people feel included in the story, because it's not just for us beloved science geeks, it's for all of us. I mean, we're to make material make people feel like they have a place at the table for planetary science and astronomy in general and all that good stuff.
And I'm so pleased that we get to start bringing this idea of connecting art and astronomy to CosmoQuest, and I'm so glad that you're one of our new partners as we move forward with our NASA cooperative agreement. And I'm so glad for all of you out in the audience for being there as supporters of the show. As I said at the top of the show, this is a community-supported podcast. This is not paid for by NASA. This is, in fact, paid for through donations from people like you. So thank you for giving, and you can learn more about the show at patreon.com/learningspace. Georgia, you have any news that you want to share before we sign off?
I don't think so, except to be watching for our educators newsletter, which is going to sort of debut with the new grant and all that very soon in the next couple weeks. I think that's the only thing I have at the moment.
So thank you for joining us. Thank you for following, and keep up with all that we're up to between the episodes by following us on Twitter, Facebook, all of the places. We are usually CosmoQuest X, where X marks the science. So thank you, and have a good morning, afternoon, evening, wherever you may be in the world.
That's right. Thanks, everybody. Goodbye.
Bye, everybody.